Hello everyone. We, the final year students of GOIST Guwahati University, Dhanraj Kashyap and Navin Sharma are going to present to you our project titled IoT based smart mining helmet for hazardous gas detection and miner health monitoring. We have done this project under the supervision of Dr. Kondorpa Kumar Sharma and Dr. Lasit Datta, and also under the co-guidance of Dr. Surajit Deka. Our project basically aims to enhance the safety and well-being of the miners in underground mines by monitoring their health and working environment using various sensors and IoT technology. In the underground mine, there possesses several risks and challenges for miners, including exposure to hazardous gas and poor air quality. Traditional safety measures may not be always efficient in providing timely alerts or accurate monitoring. So we have decided to develop a smart helmet that can address these issues.
So these are the literature reviews we went through. Problem formulation. So firstly, what we have done is we have tested all the sensors individually and checked the reading if they are accurate or not. And after that, we have integrated it, and then we have applied some algorithm to get some predictions of the machine learning model, and also we have calibrated the MQ gas sensors to get proper reading in ppm values, and then at last we have sent the output to the web server. So these are the hardware components we have used in our project. The first three MQ sensors are used to detect the gases, harmful gases such as carbon monoxide, carbon dioxide and methane. A photoregister, body temperature pulse oximeter, buzzer, node MCU and temperature and humidity sensor. Technology use. These are the technologies we have used in our project. Machine learning. In machine learning, we have used the support vector machine, which is used for classification and regression results. We have used it for our health monitoring prediction.
So in the IoT based health monitoring system, we have basically used the sensors DS18B20 for measuring the miner's body temperature, MAX 30100 for real-time monitoring of the BPM and oxygen level of the miner. We have also used the DHT11 sensor so that we can know if the environment is efficient for working or not. This is the block diagram. This is the flow chart. You can see firstly we initialize the modules, then we acquire the sensor data of the miner, then we see if the values are available successfully or not. If no, then it again acquire the sensor data, and if yes, we move on and display the values in the monitor and then send into the cloud to display it in the web server. This is the circuit we have made, the hardware part, and there you go. We have uploaded in the web server, and you can see how the parameters are displayed. Here the parameters are perfectly normal. These are the parameters taken in normal environment.
So moving forward to the next step, we have decided to integrate gas sensors as well as LED with a photoregister for a better model. So gas sensors, we have used the MQ7, MQ135 and MQ2 for harmful gas detection such as carbon monoxide, carbon dioxide and methane. We have also used a photoregister with LED to control the intensity of the light automatically in the environment. So this is the block diagram of our module. Here we have connected all the sensors that we are going to use for our project, and then we can see that in the output we have buzzer, LED, web server and IoT platform. So if any of the gases exit, the buzzer will ring and the LED will control as based on the LDR. So this is basically the flowchart of our project. Firstly, we initialize the module and then we acquire data. If the data are available, we move, we send the data in the three parts, such as we pass the SPO2, BPM, and body temperature for health monitoring to get minor health indication, and we pass the carbon monoxide, carbon dioxide, and methane, and then we see that if any of the threshold exits. If yes, the buzzer will turn on. If no, then we move on to the next step and display the data on the web server with the health prediction data as well as the real-time data of the miner's health. And light intensity, it controls according to the environment, that if the environment have enough light, the light will be the LED will be off, and if the environment have a very minimal amount of light or maybe no light, then the LED will turn on automatically. So this is the module circuit of our project. So for health monitoring prediction, we have collected data from the Kegel. These are the three parameters we have kept in mind: BPM, SPO2 and body temperature. The algorithm we have used is support vector machine algorithm. So this is a block diagram of the health prediction model. Calibration of the gas sensors. Calibration is a very important process when we are working with MQ sensors. The MQ sensors need a proper heating of 24 hours to 48 hours to give you accurate reading. So for calculation of the ppm, what we have done is we have got the resistance ratio of the sensor, and then we have calculated the slope and the y-intercept, and then we have got the resistance in the fresh air, and after that we do following calculation to get the values in ppm. The same process is for the MQ9 sensor and as well as MQ135 sensor. So this is the proposed model. Here we have used the breadboard to see that if everything is fine. Now we move on to the next step, and we have designed a smart mining helmet. This is the prototype.
We have integrated the sensors.
So we can clearly see that we have integrated all the sensors which we use in the breadboard to detect to get minor health indication as well as detect the harmful gases of the surrounding. And also we have used a LED which controls automatically. Here we can see that when the room has not minimal amount of light, then the LED goes on, which means that the environment is dark. Here when I flash my phone, then I can see that the LED automatically goes off. So for that we have defined threshold for LDR, that if any of the threshold, if the threshold exceeds, then it will go to off or on. We can adjust this manually. So language and software that we use: Node.js is a JavaScript runtime environment. We use it for the backend of our project. The Tailwind CSS is used to develop the front end, and this is why we have used it. So here are the results of our proposed IoT model. We can see that we have sent the data to our web server. Here we can monitor the overall data. Here we can see the gases level in ppm, the predicted sensor data of our miner's health. If the health condition is unhealthy, then we can see that it is predicting that the miner is unhealthy. So future direction, we have, although we have proposed a model, we are left with many things. We can integrate PM 2.5 sensor to read the air quality index of the environment. We can train machine learning model with more algorithm to get a proper accuracy to make a better prediction. And we can also and we are focused to develop a proper web development of our project. So in conclusion,
So in conclusion, so to conclude, we have developed an intelligent helmet that is designed to monitor various activities related to a miner and also the mining environment. So we can say that by using this helmet, the worker can take appropriate protocols to ensure his safety. Thank you.
so this is our model. Here we have integrated the ST11 sensor, max sensors, which are the gas sensors. Here we can see that we have also attached a buzzer which will make sound when any of the parameter exceeds. Here we have also added a LED which will control its light intensity according to the environmental intensity. Here we also have a max 30100 sensor which is used to read the SpO2 and BPM level of the miner. So we have integrated all the sensors to our microcontroller which is ESP32.
So you can see.
Our model to dekha
So now my friend Navin is holding on the body temperature sensor, which is the DS, and the max 30100 sensor, which is monitoring his BPM and oxygen level. Now let's see what his parameters are. As you can see, his parameters are oxygen 98, pulse 96. All of them are normal, so it's showing healthy. As you can see on the screen, it's showing healthy. Now he has removed his hand from the sensors, so there is no reading. So obviously the oxygen is 0, pulse is 0, and etc. And the prediction is unhealthy.
So now, as we have done the health monitoring part, now we move on to the next one, which is the gas sensor detection. So we have added 3 sensors which are MQ7, MQ9 and MQ135, which are responsible to which will detect carbon monoxide, carbon dioxide and methane in ppm values. So now we can see that the buzzer is making sound. That means that any parameters of the gas sensors has been exceeded. It may be CO, it may be CO2 or methane. So for now I have placed a threshold of 500, and I can see that when the carbon dioxide exceeds 500, the buzzer is making sound. And when it will go below 500, the buzzer will not make the sound. But it is not the actual reading. We can adjust the threshold. But for now, to demonstrate our model, we have adjusted the threshold to see that if our model is working or not.
So friends, as you can see, the LED is on. This is because the room is little bit dark, which is imitating the environment in a real coal mine.
We can adjust the threshold.
We can also adjust the threshold of the light intensity.
So now I will.
So since we can adjust the threshold, we have decreased it deliberately to show how the model works. Now, as you may think, why the LED is on despite that the room is lit. So now the LED is on. Now if my friend flashes the flashlight on the photoresistor, you can see the LED goes off. This is because there is enough light in the room. So, this would be of immense help to the miners working in the underground mines, which may be very dark. So, to conclude, we have designed an intelligent helmet which will monitor the various activities of the miner and also the mining area, thus helping the worker to take appropriate protocols to ensure his safety. Thank you.